So let's start with the chapter number first, that is storage classes and that unit number 1, storage preprocessor, processor and storage classes. Okay, so that is our chapter number first. And let's start with the first unit. Just I will mark it as an blank. Okay. Preprocessor and storage, unit number 1. Preprocessors and storage classes. The preprocessors is exactly what its name implies. It is a program that processes our source program before it is passed to the compiler. Preprocessor commands, often known as directives, from what can almost be considered a language within C language. We can certainly write C programs without knowing anything about the preprocessor or its facilities, but preprocessor is just such a great convenience that virtually all C programmers rely on it. So C processor is not part of the compiler, but it is separate steps in the compilation process. So in simple terms, C preprocessor is just a text substitution tools and to instruct the compiler to do required preprocessing before the actual compilation. We will refer the C preprocessor as CPP, that is object oriented programming language. So C processor is a separate step of your compilation process. Okay, before we compile the programs, the program is going to be preprocessed. All preprocessor commands begin with a hash symbol. So whatever the preprocessor commands are there, preprocessor directories are there, that directories or commands starts from your hash symbols, then it will consider as a this is a preprocessor directories. It must be the first non-blank characters, and for readability preprocessor directories should begin in the first columns. So this is your actual figures of C processor directories. So first is a C source codes, that is our programs and preprocessors. This is our preprocessor directories, and these directories will always start from the hash symbols, and then compiler will compile the programs. Source code, preprocessors and compilers. So the C preprocessor is a micro preprocessor, allow you to define the micros. So these processors are the micro preprocessors which allows you to define the micro that transform your programs before it is going to be compiled. So this transformation can be inclusion of header files. Transformation can be inclusion of your header files like micro expansion, etc, etc. So whatever the preprocessor directories are being with a hash symbol, so this is the example for the preprocessing directories. Hash define pi 3.14. So hash define is nothing but our preprocessor directories, pi is nothing but the variables, or we can also call it as an value of pi is 3.14. so we need to define these preprocessors at the beginning of your programs. So that is about the preprocessor directory. Let's see some of the common use of the preprocessor directories here. So first is including the header files in your programs. So hash include, so this is one kind of preprocessor directories. Hash include preprocessors is used to include header files to C program. So this is the directory which we are including the as a header files in your programs. For examples, hash include stdio.h. So here stdio.h is a header file. So standard input output directory is .h. So h is nothing but the header files. The hash include preprocessor directories. Replace the above line with the contents of stdio.h header files. That's the reason why you need to use hash include stdio.h before you can use the function like scanf and printf. Okay, so stdio.h is nothing but the standard input output directory dot h. Then this header file which are containing the two main functions, that is printf and scanf. So next point is the micro expansions. So micro using hash defined directories. So micro is a fragment of code that is given a name. You can also define the micro in C using hash defined preprocessor directories. So micro is nothing but the fragment of code. We can also call it a small part of your programs. So examples are given: hash define C and then value. So that C and value is nothing but the C is nothing but a variable, that is nothing but the values. Here when we use C in our program, it is replaced with that values. It means that whenever you are using the C in throughout your program, that C variable is replaced by with these values. So that is for the micro expansion. So let's see the example for the micro expansions. So hash include okay, so hash define preprocessor directories and hash stdio.h. Hash include that is nothing but the standard input output directories .h and hash define pi 3.1415. So pi is nothing but the preprocessor directories. So let's see a float, that is radius and area. So in this example we are calculating the area of circle. Okay, so how to calculate the area of circle? What will be the formula for calculation of area of circles? So pi into r into r. So that is the formula to calculate the area of circle. So let's define the header file, that is hash include stdio.h. This is your header files and this is a hash define pi 3.14. so this is a hash define pi 3.14. this is your pi 3.14. this is your value of pi, and we can also call it as an micros. Now program starts from your main function. So in this program we need to calculate the area of circles. So to calculate the area of circle we require two parameters like radius and area. So radius and area is always in the integer variables. Okay, and when we are calculating the area of any of circles, we are getting the value in terms of pointers. So that value will be considered here, that value will be declared as a float, radius comma area. So float data type is used for the storing the pointer numbers. Then printf enter the radius. Printf enter the radius. Scanf percentage of f comma and radius. So percentage of f is nothing but the float comma and radius. Now how to calculate the area of circle? Pi into r into r. So here I have written the formula. Area is equal to pi into r into r. Now print the area of circle's area is equal to percentage of point 2f comma area. Okay, so that is we are printing the value of area and then return as in 0. So why here written as in 0? Because in the main function I have written as an int of main. So int is nothing but the int is the data types. So and the output will be the just I'm going to write here output is equal to, suppose our area is so radius is 5 into 5 into 3.14. so that will be the output, I think 78.0. so this is the calculation area of circle. So let's see another function like macros. Okay, so you can also define macro that works in the similar way like a function called this is known as function like macros. For example, now how to define the macro can define at the start of your programs. So function like macro, we need to define the function at the start of your programs. So hash define. So let's see the examples. Hash define circle area in bracket of r. Hash define circle area in bracket r pi into r into r. So this is the calculation of area of circle. Okay, and circle area is the keyword the r. Every times the program encounters circle area, that is argument, and it is replaced by pi into argument into argument. Suppose we pass 5 as an argument, then it expand as below. Okay, so we have passed 5 as an argument, then it expands as below. Circle area of 5 expands to pi into r into then here we have passed the passed some parameters to macros. Okay, let's see the example to calculate the area of circles. Now here in the previous example we are defining the only value of the pi, but here we are defining the functions as well. Hash define circle area, then parameters and then arguments. So that of things is common, enter the float radius comma area. Printf, enter the radius, scan a percentage of f comma and a radius. Area is equal to circle area in bracket of radius. Okay, so that this is nothing but our function. Okay, we are calling the function, we are called here function, that is circle area in bracket r is nothing but the radius. Now put in the area circle, printf area is equal to percentage dot 2f comma area and then return as a 0. So output will become the same 78.0. So these are the some macros are there and directives and their description. So hash defines. The hash define is one kind of macros which is substitutes a preprocessor macros. Substitutes a preprocessor macros. Then hash include, insert a particular header from another files. We're going to insert a header files from another file. Then hash undefine, undefines a preprocessor macros. Undefined preprocessor macros. Then hash if define, return true if the macro is defined, and if not defined, return true if macro is not defined. So these are the preprocessor directories. So what is macro versus functions? The macro versus functions. So macros are preprocessed, so it means that all the macro will be processed, or all the macro will be pre-processed while it is compiled, but the functions are not pre-processed but compiled. So micro versus function, the macros are pre-processed, so it means that all the macro will be pre-processed while it is compiled. The functions are not pre-processed but compiled. In macro there is no type checking is done, so it may occur some problems for different types of input. In the case of function this is not done. Also for micro, if the inputs are not properly maintained, that may generate some invalid result. So micro versus function, macros are pre-processed means that all the macros will be pre-processed while it is compiled. The functions are not pre-processed but compiled. In micro there is no type checking is done, so it may occur some problem for different types of input. In the case of function this is not done. Also for macros, if the inputs are not properly maintained, then it may generate some invalid result. So this is example for the macro versus functions. Okay, so that include std.h is nothing but the header files, and in a hash defines square of x into x. Okay, so in this example we have to calculate the square of a numbers. For example, 5 square is 25. Okay, so in this examples we are calculating the square of a numbers. Then here include standard input dot at library function hash defines square x into x. So square x in x into x, that is function like macros. Okay, we are defining here functions, and integer square integer of x, this is the name of your function, and we are passing the parameters within that functions, and integer is nothing but the data types, and then return x into x. The main function we are printing the values of x. Use of square is nothing but the square root. The value of square is 3 plus 2. Percentage of d slash n square 3 plus 2. The printf use of square, the value of square 3 plus 2 is equal to percentage of d n square 3 plus 2. Okay, so the square root of 3 plus 2, that is 3 plus 2 is 5. So so square root of 3 plus 2 is 25. Okay, so that is the 25 will be the answer. And second printf statement, use of square. So square is nothing but the value of x. Okay, so 3 plus 2 square of x is nothing but 3 plus 2 into 3 plus 2. So 3 plus 2 into, that is 4. 3 plus 4 plus 3, that is nothing but the 11. We'll see the explanation for the same. So 3 plus 2 into 3 plus 2, 3 into 3 is nothing but the 6. Okay, and 6 plus 3 plus 2 is nothing but the 11. So let's see the explanation. The functions and macros, we want both will do the same task, but here we can see that output are not same. This main reason is when we are passing 3 plus 2 as a functional argument, it converts into 5 and then calculate as a 5. 5 into 5 is nothing but the 25. For micro, it is doing 3 plus 2 into 3 plus 2. 3 plus 6 plus 2 is equal to 11. So the macros are not recommended for the following problems. So there is a problems in for this problems the macro were not recommended. The first is there is no type checking is done in the macros. Default to debug, so they cause a simple replacement. It is very difficult for the debugging. Okay, so they causes the replacement of macros. So macro increase the code length that it is added before the code file pre-processing. With the use of macros, the length of your program will get increased. Okay, so the code file pre-processing. So this is nothing but the macro versus functions. So one more things, macro does not check any compile times errors. The macros are pre-processed. Okay, and then after pre-processing you will go for the compilations. Okay, after pre-processing it will go for the compilations. So next is the